Lesson 1.4 on page 32. If you are not there in your book, go ahead and pause the video and open your book. Okay, so we're going to look at a power of a power. So this rule says to find the power of a power, you will multiply the exponents. So when you're finding a power of something that already has a power, the base will stay the same and you will multiply exponents. Like, for example, 5 squared to the third power. So we're finding a power of something that already has a power. We're going to keep the base the same and multiply the exponents. 3 times 2 would be 6, 5 to the 6th. Okay, let's look at 6 to the 4th to the 5th power. Okay, one way to do this is to write out 6 to the 4th 5 times and multiply, because that's what this says, 6 to the 4th 5 times. So we could write 6 to the 4th times 6 to the 4th times 6 to the 4th and a 5th time. And then because we are multiplying all the same base, we would keep the base and add all those 4s. Or why do all that when we have a rule for finding a power of a power? So we can take this shortcut and apply this rule and keep the base the same and multiply these two numbers. 5 times 4 is 20, 6 to the 20th. Okay, let's take a look at another one. Let's try 8 to the 4th to the third power. Okay, so we're finding a power of a power, so we're going to keep the same base and we will multiply the exponents. 3 times 4 is 12, 8 to the 12th power. And same thing for variables. K to the 7th to the 5th power. Okay, we're finding a power of a power, so we will keep the k and multiply 5 times 7. So k to the 35th power. And let's take a look at this one. 3 squared to the third power. And I'm going to put a set of brackets here. They're just like another set of parentheses. And then all of that squared. So we're finding a power of a power of a power. So we're going to solve this the exact same way. We're going to keep the same base of 3 and multiply these powers. 2 times 3 is 6, 6 times 2 is 12, 3 to the 12th. Okay, now what if there is more than one kind of base inside? More than one kind of base inside your parentheses. For example, let's take 4p cubed to the 4th power. So you're finding a power of something that already has a power, but this time there's more than one base. So you have to extend this outside power to every different base inside. So we're going to apply that rule. There's an invisible power of 1 here. This is 4 to the 1 power. So we're going to multiply 4 times 1 for 4. So the base of 4 stays the same. 4 times this exponent of 1 is 4. And then we're going to do the same thing to the variable of p. So this is p, and 4 times 3 is 12. And then we can't keep it in this form. We need to solve this 4 to the 4th power. So this would be 4 times 4 times 4 times 4, which is 256 p to the 12th. Okay, let's take a look at one more. How about negative 2 m to the 7th, n to the 6th, and then all of that to the 5th power. Okay, so that we have 3 different base numbers in here. So we need to remember that this is negative 2 to the 1st power. And now we're going to take this power of all of these, we're going to multiply. Multiply the power of 5 by all of these powers. So I'm going to bring the negative 2 down. And 5 times 1 is 5. So that's going to be negative 2 to the 5th power. Okay, we're going to bring the m down. And 5 times 7 is 35, so m to the 35th. And I'm going to bring the n down. 5 times 6 is 30. And now I just need to simplify this negative 2 to the 5th power. So that means I will write negative 2 5 times. So let's make some groups. 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, 16 times 4 is 32, and there is an odd number of negatives, so my answer there is negative, and then I just bring the M 35 and N 30 down, and this would be my final answer. All right, we will practice more tomorrow.